let's take a look at what we're going to work today in our demo. So we already have in place our data set on our project AOI. We have our well information as well as our seismic data set added. So a couple things we're going to work through today. A quick demonstration on how to perform the balance, the seismic balance in 2D and 3D. Synthetic generation using the new scene view, which is added to GeoPhysics 2019.3, as well as a visualization or horizon interpretation main workflow, a briefly touch on the conversion, and finally a map generation and depth, and our final output, which is a documentation or a printout map that you will use to either a report or a PowerPoint presentation that you may need. So let's go ahead and jump to that demonstration. So as we said, this is a typical configuration for seismic interpretation. So we may have several 2D lines, well information, and also 3D survey. Let's begin, as we mentioned, with the 2D seismic balance. So here is a composite line that goes through the 2D lines, and we can notice that there's a difference in our seismic information or seismic line. So a couple ways we could go through and tie this or fix this information, this mistie, is by right-click, interactive line tie, and when that pop up, we have several options here. So we have that intersection of that 2D lines that we have selected. We could play with the color palette on both, set some parameters. Let's say, for example, a time window of interest. So we could work here better. And here we could see, notice this difference. So we have our one line on the left, LBT, and then the MHD line. And you see the correlation. We also have the map location and the amplitude spectrum. So we notice that there is not a good correlation between the two. And what we have to do is now apply a static shift, a gain, and also a phase rotation in order to make it tie. So we could easily do the auto calculate. So that will have give us a better correlation and already have improved. And these are the values that needs to be corrected in order to have that in. So once we're happy with this, we can right click. Oh, sorry, we could click save as version, and this will give us the opportunity to save a specific version for that 2D line only. Once we're happy, we could set it as an active version, and it will do the shift and fix that. But there's a better way. So this will work if we have just a few 2D lines like this example. But if a better approach to that, if we have a regional project and if we have tens or maybe hundreds of 2D lines, it's use the interactive, the seismic line balance. So this will give us a pop-up window that will allow us. Let me walk you through quickly to do an automatic or a semi-automatic tie to all those 2D lines. So the first thing we need to do is select our reference line. Let's see, we could just apply for this example as 101. We could select the list of 2D lines that we want to apply, the correction, build the list, and then we could compute misties. Once that's done, we could apply the compute shift. So this will give us a message that tells us that all the combination of those 2D lines, 2D lines had been corrected. We could see the table, and as we notice that there's small correction between a few lines, and then the other one, if we need to edit, if we're not happy with it, click on it, edit, and we have the option to update these values. And once that's done, click OK, and then we can process lines. So once that's pop up, we have the option to select which lines we want to apply the correction table that we created, save it a name, give it a version, and we could save as active. So once that's done, we click the save as version in this case. So the very easy way is, especially as I said, if you have a regional project that we have several 2D lines. And now one way just to notice is the changes. We had created this previously. We just go under database, the dataset version, and save the balance one that we had created, and you notice how it had been improved. There's a better tie between the lines. Also, there's another application or ability to do a tie between 2D and 3D survey. So similarly, we can right click, click interactive tie line, and this will give us again the same pop-up window where we can set the parameters and again do the tie, in this case between a 2D line and a 3D survey. So once we click that, again we see small correlation. If we're not happy with it, we could toggle off any parameter. Let's keep the gain as fixed, and we could auto calculate, and there's give us a change, and the correlation has been improved. Once we're happy, we could click as version, save as version, and this will give us the opportunity to create a new version or a correction version to the survey that we already had in our session. And once that's done, we could click and update our table, and just to show you the data, click and click that save balance. So now we have set, as I said, we have a correction. We have corrected the 2D lines and the 3D survey, and now the next step we're going to move is to do the scene tool or synthetic seismogram, and now and show you how it's done with size. So let's change the gears a little bit for the next step, and let's use the 3D view in order to create our synthetic seismogram. So in this case, we have our 3D survey. As you can see, we have a well and a cross line cutting through well 03. So in order to launch scene view, we highlight the well right there. Click. It's blue highlighted, then right click and create edit synthetic. So once that's pop up, we have information. So we will need definitely a sonic and a density log to create or build our synthetic seismogram. Also, a few things here to notice is we have the ability to choose a 3D survey, which in this case we're going to use the balance, which had just been performed in the previous step, and or we could choose a 2D line in this case. Also, the ability to change the orientation, either cross line or inline. We're just going to leave it the default, but the important key is here to have those ability to check right here our sonic density and our seismic data set. If one or the other is missing, there's also a log curve estimator that will help us to generate one against the other one. So let's open scene view and see how that looks in this new setting for 2019.3. So right here, just few things to explain. So we have a sonic density, we have our impedance, we have our interval velocity, a drift curve, and a reflectivity. And this is the synthetic trace which is being generated by the convolution between the reflectivity and a Richter wavelet in this case, which is the default. So that has been launched, and also we have the seismic data set that we're using right now. So in our exercise, what we could do, there are a couple parameters that we could change here. If we toggle on or highlight a specific column or panel, that will change up here, and we could change the information from specific seismic. Let's just move this slightly here. Just scroll down and see we have our horizons, we formations, sorry, and from the contrast right here, we have that mark at this location and a reflectivity. So the first step we will need to do is definitely extract the wavelet from our data set, which is ideally performed right here in extract wavelet. So once that's ready, we could click from 3D seismic, or actually where we have selected our display traces or the 2D information. So in this case, we have 25 traces, and we could change the range. Let's say our time window to work, and just click. We could save it as extracted wavelet. So the ideal thing to do is extract our wavelet and work with the wavelet extracted from our data set. Once we're happy with this, let's just give it a number 2. Extract wavelet, and you could see that also. And once we're ready, we could click save, and that's the one that's going to be applied, and it's been applied actually to our data set. One thing additionally we could do is compare several extracted wavelet, and we could do that by clicking on edit wavelet. So this will give us the option to see different extractions or default. We could also customize this and change to have a better analysis. So the extracted, what we just perform is this one. You could change the color and have that comparison between a Ricker, which is the default, and also compare the amplitude spectrum from that. Just to have a general idea, and also we could actually generate an average one, which is also the combination of all of those that had been present, and we could just see how that looks. And this gives us opportunity to do a better analysis on our data, on our wavelet to be extracted. So let's say we're happy with this one. We're not going into the details, but just a quick workflow how to do that synthetic tie. So let's assume that this synthetic or this event that we see here, this peak, will match this main reflector right here. So in this case, just a simple approach is click on well tie, and we're going to do is just click on drag, and that will give us the opportunity to push this down and just have that bulk shift of the data set. So we'll see that there's a better correlation here. One of the things we could do just to notice also is if we have click on the synthetic just to have a little bit of a better gain on our data set, to have a better contrast. So let's say maybe 10. So this will give us a chance to see better how that synthetic or wiggles behave compared to the seismic. See one other thing. If we're not happy with it, we could also click undo, redo, and accept the commit to accept the changes. But the other before we do that, one important tool is the correlation, which allows us to, as it says, just correlate our synthetic traits with our seismic data set in the same window that we're working, and do that analysis and understand how the data is behaving. So the ideal to have is highest correlation possible. So there's also a tool here that allows us to get the information from that correlation and apply a maximum correlation tool. And this will give us this opportunity to have that, and that will be the one applied to our synthetic. So once that while we're happy with this, we could click update, and then we'll just click save the changes, and you notice that there's a slightly change here. So basically it's provide us with the better correlation in terms of shift and phase rotation for that data set. So once we're happy with this, we could also, as I said before, click on undo, and also the drop down to give us several steps to undo. But if we're happy with this, we'll click on commit. Let's just say we're just gonna replace an existing one. It's this one already created. So we'll just, in this case, override. We just click continue, and then wish to continue, and that's done. So that is saved to our database. And now we're going to take a look at that in our 3D view. So let's just minimize this, go back to our 3D viewer, and we have our well and with our synthetic right in there. In order, we could do a few manipulations here on the well to set the display of the synthetic. So we just go into log curve, we have the synthetic configuration, and we could add maybe a few more traces, so you notice that it has a better way to look into our data set. This as well as turn on the formation tabs. We could also have the opportunity to apply a color or naming. So this will allow us to have a better understanding of what's the reflector and how it looks compared to our data set. So we have the formations, we have our seismic, our trace, and our synthetic trace to see how we had tied our data set, our well to our seismic. So this is a portion for the scene view, and now we're going to move to the horizon. Let's stay on this view for the horizon interpretation. So let's click the display setting on the well, and let's start with assume that this is a reflector that we're going to work with, so that it's tied to a formation here. And also I will explain a little bit of the manipulation or the display on the sessions in the 3D view. So the first thing we need to go to Horizon tab, create new. So let's say we're going to use a WAB as our name for our horizon, and we're going to do a depth conversion as the usability as the end workflow. We will have our data in depth. And here's a new an addition to attach right here to our a formation, and when we create. So now we have that in, and it's already here active. We click here to set it. So as we said, we're going to do an interpretation on this reflector. So let's a couple ways to do it. We could just click a single pick, 2D auto pick, and a few other polygon pick and drag pick. So let's do the 2D pick. So this is an ideal way to go right into our interpretation here. So what we have noticed is that it went through along the cross line in this case to get that interpretation of this section. So what we could do is increment in one direction and then just click, and it's been set here to go every 10th. And one way, this is a nice addition on 2019.3 that we have the toolbar down here, and we could set right here the increments and or jump in this case for a specific value that we want. If we, like this case, we have committed a mistake, we could just go back here and then click undo, and it just go back down to this previous clicking. Or also we have the drop down, we could go back several steps behind and see and update our horizon. Similarly, we could have that display in our map, and one of the things we need to do is just turn it on our view. Needs to be added first. Let's just expand, and we have this one right here, and then we could click here, go to map view, and just zoom in just to show if you did this increment and where we had done the interpretation. We could go one more. If we highlight or active one more time the 3D view, and either use the arrow on our keyboard or use this tool, we can move and do the interpretation, and you could notice how it's been populated in our map view. This works very nice to have a reference as a best practice. We could also right click in our seismic line, and we could change directions, and we have the opportunity and the ability to see in the other orientation the horizon that we're picking. So in this case, we have noticed that this is intersection. We could click here, and you notice how it's been performing this line. We could also, as we have changed the inline, we could go back and continue either with the arrow on our keyboard or clicking this tool option right here. Now we could complete this process, but in the interest of time for this demo, I just want to show you a few things here on the horizon part. So once we're happy with this, we can go onto the 3D auto pick, click correlate, and this will allow us to have the full interpretation, or it will do the correlation of the seed as we had interpreted, as we could call it. Few tools that we could do here in order to QC properly our horizon, and let's just turn off the view of the seismic data set just to look at our horizon. There you go. So, and let's turn off the wall just to make it easier and not busy. So one thing we could do is click on pick attribute, and we could actually add it to our right here, down here. Okay, we had toggle our pick attribute tool in this on this side of the window. And what we could do is we could click on our horizon or recently interpreted horizon, and we could do a few things here. So one, click out to pick. We have selected our pick attribute by clicking on the horizon. So here we have a few things that we could do. We could set the confidence on our interpretation. So 0 is it will expand as all over. We could reduce or allow this interpretation seed to expand, and if only pick if we have 80%, in this case 80% of confidence on the pick. If not, we could reduce this to 50, and that will give us the opportunity to QC our data set. Also, we have the ability to click the path. So in this case, what it does, it will give us the path. In this, you could see in light color, and we could change it right here. What has been the child picks to the parent that comes from this one on the interpolation process. So for example, if we click on along the path, and we'll see all these colors that we have here are the ones representing the descendants from this blue dot right here. So if we click that, one thing we can do if we don't like that interpretation of what had happened after this point going forward, we could just discard that. And this will give us the message that it will just remove that interpretation on that pick. Similarly, as you notice, so as we do in the interpretation on our 3D view, it will also be updated in our map view as well. So this is also a good functionality. So to QC, is there places that we don't like the interpretation or what had happened in this area, we could click previously and then just highlight, and if we're not happy, just click discard, and that will give us the option to delete that section of the data that we had interpreted. And this is what has been done here. Let's just click undo and then redo one more time just to show you that how the correlation had worked. And now this is a good tool, a way to have the correlation in the 3D view and also in map view. Similarly, we could also have this same information display in our classic view, which is the previous one. So let's just minimize that, and we could see right here how that interpretation has been performed in this view. So this is our same horizon, and we could right click, expand here, and see this is the one we've been working on. So right here we have our interpretation in our 3D survey. And here's the correlation along the line, and also we could continue our interpretation if we wish to do so here by selecting our color palette and have that selected here. So we have highlighted as well the same horizon that we're going to work with, and just by clicking here, sorry, this one to expand, will allow us to get that interpretation. So what we've done now is just moving from the 3D interpretation to the 2D line just to complement that. So this is also along the 2D lines. We could click this, excuse me, this one right here, and let's just select the 2D line in order to get that interpretation in. So that's the longest or the longer 2D line in this case. Let's just make sure that we're doing the right. We want to do the balance one, okay, and that's the interpretation that we have, and we just need to continue the piece or the portion that we don't have interpreted. So click right here. Oh, didn't we have the active one? Oh, set as active. Oh, let's just refresh for some. There you go. just refresh the view. So here we notice that there is the extent of that interpretation on the 2D lines as well as the 3D. Similarly, we could just take right here, I'll click on the 2D line and continue that interpretation. Let's just ensure that this is the active version, yes, and then we'll just click on that and just continue, complete that interpretation right here. So now that we have done this interpretation, this we need to cover our AOI. So we have our AOI, we have our interpretation on our survey, in our 3D survey, and also we extend it through our 2D lines. The next thing we need to do is go under interpretation, grid our time. So that is extend our interpretation along our AOI in time, and then we could click here to get our grid in our velocity grid already generated, and then we can go here and then grid velocities one more time. It will be the same as it was already previously created, and then go under depth and also the ability to convert to depth. So this has already been added to our session. So once that's done, this is almost done on our final steps to get our process in our AOI. So in this case, we already have our horizon interpretation of incorporating all the information that we have. We had this survey, 3D survey, we have our 2D lines, and also had been controlled by a well. Now, we need to get this as an output. So one way to do this, fairly easy, is to go under File, New Quick Map. So this will allow us to create a presentation type or report type documentation or map that we might need to add to our report document. So they will give us a wizard here. So we could adjust the color palette if we're not happy, if we don't like this one, we could maybe click a different one as if it's going to be printed out or such. We're just going to keep a few things by default, but just to change a few of the others. So we want to have our color bar, north arrow, north tidal, scale, surface data. So what we're going to do, basically, we want to have our horizon and depth, which we already had created. So is this one. Click OK. So that's just going to be gridded, and then size. In this case, just for this exercise, just keep it 500. We also have the abilities to edit or add information on our title block. So the main default data has been added from our when we set the project, but we could also add some information if we need to. We're just going to leave it by default in this case. So we could also have culture data to be added to this quick map if we have any, as well as faults, and fault we could fault as well if we want to display that information. Let's just change here parameters to fix a few things here. So once that is done and we're happy with that information, we'll click close, and that will generate a output for that map. Let's see how that looks. So we could, if we need to do some editing on the quick map, we could go right here under quick map, adjust quick map. This will give us again the table or the wizard to modify any information that we may have here. Also, we could click zoom to quick map. Let's say in this case, going back to 100. So that is the information that we have. So once we're happy with this, we just did a default data set. In this case, we have the color bar, we have our control line, 2D line information or 3D survey as well added, title block. And this is already a few step or a single way to get our map generated and ready to have that output. So if we're happy with this, click File, Save as a meta file. If we want to, you just click here under our root and give it a name. Let's say map 1. EMF. So that will give us that version that we could open afterwards in a video image editor software tool uh, or any other. We could also have save as a PDF if we want to print a PDF. Right click, save it, and this, let's just give it one name, 2. So let's take a look of the PDF file that we had created. So it's already clean and crisp and ready to be used in another version, so or another tool. See, we could zoom in a little bit more. We have our coordinates, we have our line information, or surveyor information from our horizon, tile block, or color bar, pretty much ready to use. We could have that already set to a PowerPoint, for example, or a documentation or a report, as I mentioned. So this concludes our demo. Just a quick recap. We touched on seismic balance, on seismic data set. The scene view capabilities improved, new capabilities on scene view for 2019.3. Few things on how to perform a proper horizon interpretation using 3D and 2D as well. Map generation, and our final report or output maps in order to be used as a for a presentation on or a report.